So right now we're going to be talking about section 5.7 in our geometry book, which is proving special quadrilaterals. We've been proving parallelograms, but now let's see how we can prove all those other special quadrilaterals. Proving a quadrilateral is a rectangle. Now, for some of these, there will be two cases. If you can prove that's a parallelogram and you can prove it one step further, you can do that way. Or if you can prove the special case under if it's just a quadrilateral, you can do that as well. You just have to be careful that you don't try to mix them up. You can't, for example, just have a quadrilateral and have at least one right angle and not prove that you have a parallelogram first. So, a parallelogram is a rectangle if, as I just mentioned, it contains at least one right angle, or if the diagonals are congruent. And we see why this can be tricky because, well, a trapezoid can have a right angle, or an isosceles trapezoid can have diagonals congruent, so you do have to prove that you have a parallelogram first. Or a quadrilateral is a rectangle if all four angles are right angles. If you have that, you don't need to prove that it's a parallelogram. Proving a quadrilateral is a kite. A quadrilateral is a kite if it has two pairs of consecutive congruent sides, or if one of the diagonals is the perpendicular bisector of the other. Often you'll be able to prove one, not necessarily both, at least easily. You could probably prove the second one through some work, but one will probably typically fall out a lot easier than the other. Proving a quadrilateral is a rhombus. A parallelogram is a rhombus if it has a pair of consecutive congruent sides and if a diagonal bisects two angles. So if you prove that you have a parallelogram and one of those two other possible qualifiers, you have a rhombus. Or a quadrilateral is a rhombus if the diagonals are perpendicular bisectors of each other. Proving a quadrilateral is a square. A quadrilateral is a square if, well, we've kind of seen this all along. The square is not particularly unique except for the fact that it is unique in the fact that it is none of its own properties. So it's both a rectangle and a rhombus. If you're able to prove something's a rectangle and you're able to prove it's a rhombus, you've got yourself a square. Proving that a trapezoid is isosceles. A trapezoid is isosceles if the non-parallel sides are congruent, the upper or lower base angles are congruent, or if the diagonals are congruent. So if you have yourself a trapezoid where you see that you have your consecutive angles that are supplementary, proving that you have the one pair of parallel lines, then you have an isosceles trapezoid if you can prove any of those other cases. Alright, let's give the most descriptive name for a quadrilateral whose consecutive sides are 15, 18, 15, 18. Now, it can be kind of hard to visualize this, so just draw yourself a non-assuming quadrilateral. Read it as a scale because you're not assuming anything. So we have 15, 18, 15, 18. So, I see that opposite sides are congruent. Therefore, my most descriptive name I can give it without any more information is going to be a parallelogram. Number 2. A quadrilateral whose consecutive sides are 15, 18, 18, 15. Alright, so let's draw this again, a non-assuming quadrilateral. Again, because we don't want to assume anything. So, I see I do have sides congruent, but they're consecutive opposite. So, in this case, I have a number 3, a quadrilateral whose consecutive angles are 30 degrees, 150 degrees, 110 degrees, and 70 degrees. So, okay, well, despite the fact of what it looks like in my non-assuming, it appears that pairwise supplementary, my top two angles are supplementary, my bottom two angles are supplementary. So those pairwise supplementary angles are going to have to be parallel. Therefore, my most descriptive name that I can give this is a trapezoid. I'm not an isosceles trapezoid because my base angles are not congruent, but because I am able to prove that I have parallel lines based on my same side interior angles being congruent. Lastly, a quadrilateral whose diagonals are and congruent and bisect each other. So let's first think about, well, the least specific quadrilateral has diagonals perpendicular. Well, and in a kite. Congruent. Trapezoid. And each other, not just one. It happens in